Okay, so now we're gonna go to 10.3, which is about the two things in 10.3. It's about the discriminant and it's about equations that are quadratic in form. The discriminant and equations that are quadratic in form. If you look at the quadratic formula, the discriminant is the expression under the square root. Its value has an import or plays an important role in the number and type of solutions the quadratic equation will have. So let's go over that first, the discriminant, which is b squared minus 4ac. By the way, I have a handout about equations that are quadratic in form, and then on the second page, that's also in the notes. All these steps for the discriminant are written there, but I'm gonna write them down, okay? So you know where they are. So first, if the discriminant is positive and a perfect square, which means if the discriminant is 1, 4, 9, 16, and so on. So when you're doing the square root of a positive and perfect square, there's no square root in the answer and you're gonna get two rational solutions, okay? Then we will have two unequal, they're gonna be different because it's plus and minus, unequal rational solutions. And not only that, the beauty of this is actually if you go back and factor the trinomial, it's factorable. So that's another test for factorization, is factorable. Trinomial or could be binomial, okay? So if you have an expression and then you want to factor it and you don't know if it's factorable, find its discriminant. If you get positive and perfect square value, then you know you can factor it. If you get a negative or non-perfect square value, then it's non-factorable. For example, if you look at x squared minus x minus 6 equals 0 and find its discriminant, b squared minus 4ac, so negative 1 squared minus 4 times 1 is negative 6, which is 1 plus 24. Right away, I know I'm gonna have two rational solutions if I do the problem. And not only that, I know I could factor that, which actually is factorable into x minus 3x plus 2 equals 0. And you can see what the solutions are, negative 3 and negative 2. They're rational and they're different. Okay. Now, if the discriminant is 0, what happens if the discriminant is 0? So number 2, if b squared minus 4ac is 0. So you're going to have square root of 0 is 0. So you're going to get negative b plus 0 or minus 0, which is, you're going to end up with just one solution. And it's rational, okay? So you're going to have one rational solution. And also, you could factor the expression. Expression is factorable. Another case where you could factor the expression, for example, if you have x squared minus 4x plus 4 equals 0. If you find the discriminant for that, b squared minus 4ac, a, b, c. So you take negative 4 squared minus 4 times 1 times 4, you get 16, negative 4 squared minus 4 times 4 times 4 is 16, so you get a 0. So you know you're going to have one rational solution, and this is factorable. I know this factors into x minus 2, x minus 2. So you get 2 twice, which makes it one rational solution. And we factored this. So we did if the discriminant is a perfect square. We did when the discriminant is 0. If the discriminant is positive, but not a perfect square is next. And not a perfect square. Then we have two unequal irrational solutions. Irrational because you're stuck with the square root in your answer. Okay? Irrational solutions. For example, x squared minus x minus 4 equals 0, a, b, c. So b squared minus 4ac, negative 1 squared minus 4 times 1 times negative 4. 1 plus 16 is 17. So it's positive and not a perfect square. Okay, we're stuck with square root of 17 in the answer. So not only we know we have irrational solutions, we also know don't even think about factoring the expression. It won't factor. Okay, that expression 9, you couldn't factor that. And finally, if the discriminant is negative, and we know when we have a negative under the square root, we get imaginary solutions. Okay, so if the discriminant is negative, then we have two imaginary solutions, and of course you couldn't factor the expression. So if you have like x squared minus 3x equals negative 10, if you move the 10 over, a, b, c, so find the discriminant, b squared minus 4ac, so negative 3 squared minus 4 times 1 times 10, it's 9 minus 40. As soon as I get a negative number, I know square root of negative 31 is going to be I squared of 31, so we're going to end up with two imaginary solutions if we solve that equation. And don't even forget about factoring it, because it's not going to factor. So that ends the first half of 10.3. The second half is about equations that are quadratic in form. Equations that are quadratic in form, which means they are reducible to quadratic equations. Reducible to quadratic equations. And again, I showed you that handout. Make sure you go over the steps. There's examples on both pages, and that's where the discriminant is we talked. Okay, so why do we want to reduce an equation to quadratic? Because remember, quadratic equations are so lucky. They have four kinds of ways to solve them. A lot of the equations you don't know how to solve. After you go past linear, then it's going to be hard to solve equations. So if you can actually transfer an equation into quadratic, that means you can use factoring, square rooting, completing the square, or the quadratic formula to solve them. That's why. So what are those equations that are reducible to quadratic? Here's an example. So if we look at quadratic equations, what makes them so unique is the following. It's if you have a t squared plus bt plus c equals 0. I'm using t just for a reason. Okay, if it's so a quadratic equation, you know the variable t in the middle has an exponent of 1, which is half the leading exponent. So 1 is half of 2. 1 is half of 2. So any equation that has this property is called quadratic in form and can be reduced to quadratic. So any equation where the middle exponent, I'm talking about exponent, the variable, okay, in the middle, is 1/2 the leading exponent, is reducible to quadratic. Is reducible to quadratic. And how is that? So for example, let me just explain. So if I have x to the 4 minus 5x squared plus 4 equals 0. If I want to reduce this to quadratic, this is quadratic right there. So I'm going to put it underneath it. A t squared minus bt plus c. In this case, as you know, a is 1 and b is 5 and c is 4. So if I want this to look like that, then I gotta start with that part, and I gotta let t, which has a leading exponent of 1, as an exponent of 1 equals x squared. That's gonna be my switch. So if I let t equals x squared, then right away t squared, if I square both sides, it's x squared squared, which is x to the 4. So t squared is x to the 4, t is x squared, and the constants stay the same. And actually switched an equation of degree 4 to an equation of degree 2. Once you get it in this form, then you factor it, and you get t equals 4 and t equals 1. But remember, when they say solve this equation, they want x. So you let x squared equal t. Now you're gonna go back to t equal x squared, and then solve by square rooting plus or minus. So you get 4 solutions. A fourth degree equation in this case has 4 solutions. Okay. Another example. 2x to the 4 minus 20x squared plus 18 equals 0. The first thing I would do, since it divides all of them, I can divide by 2 to make my equation lighter. X to the 4 minus 10x squared plus 9 equals 0. So it looks like this equation is reducible to quadratic because 2 is half of 4. That's your test before you do anything. 2 is half of 4. So we're going to let x squared equal t as before, and then x squared squared equals t squared, which makes x to the 4 equals t squared. So x to the 4 is t squared. The numbers always stay the same. X squared is t and plus 9. And luckily this factors as well. So t equals 9 and t equals 1. And then, so we moved this way. Now we're going to move that way. So x squared equals 9, x squared equals 1, square rooted, plus or minus. So x equals plus or minus 3, plus or minus 1, and we get 4 solutions. Okay, example 3. This one I'm going to be more specific. I want only real solutions. All real solutions of x to the 6 minus 9x cubed plus 8 equals 0. Again, if you look at this equation is not quadratic, but it's quadratic in form. It can be reduced to quadratic because 3 is half of 6. 3 is half of 6. So we start out by letting the middle variable equals t. If we square both sides, we're going to get that the leading variable always is going to be the t squared minus 9t plus 8 equals 0. T minus 8, t minus 1 equals 0. So t minus 8 equals 0. But remember, we did this. Now we're going to go back. X cubed equals 8. X cubed equals 1. Cube rooted. By cube rooting it, we're getting the real solutions. If we want to solve it, we can get imaginary solutions, but we're not about to do that right now. This is enough. And we don't do plus or minus when we cube root. Okay, that's not gonna be right. So let's look at 28, page 859. We have x minus 9 root x plus 18 equals 0. The reason this will be quadratic in form is because x to the 1/2 is the same thing as root x, and 1/2 is half of 1. So we're going to start by letting the middle variable equals t. Whether it's root x or x to the 1/2, it's the same. Square both sides. So x equals t squared. So t squared minus 9t plus 18 equals 0. We can factor this. That's 6 and 3. They're both negative. So t minus 6 equals 0 using the zero factor property. T equals 6. And if you stop here, that means you haven't answered the question, because the question is to solve for x. T is what we brought up. We let this. Now we're going to go back and write root x equals 6. Root x equals 3. To get rid of the square root, we square. So we get x equals 36 and x equals 9. Since we're squaring, we better check our answers. And if you check them, they do work. Okay, it will work. All right, 34, page 859. X to the 2/3 minus 7x to the 1/3 plus 12 equals 0. As you can see, 1/3 is half of 2/3. So we let x to the 1/3 equals t and square both sides to get t squared equals x to the 2/3. So this is t squared minus 7t plus 12 equals 0. And locally it factors, minus 4 minus 3. So t minus 4 equals 0. T minus 3 equals 0. Add the 4 and add the 3. Again, it's short. If you stop right here, we're going to go back to x to the 1/3, which is cube root of x. And then cube root of x. To get rid of the cube root, we cube both sides. So x equals 4 cubed is 64 and 3 cubed is 27. Okay, there's a couple more in your handout, in your notes. I'm gonna do one more. It's 50. I don't know if I'm gonna do more. Let's see, let's look at 50. X to the negative 2 plus 2x to the negative 1 minus 8 equals 0. So what we can do, we can write this as 1 over x squared, and this is 1 over x, 2 times 1 over x. Okay, and then we let 1 over x equals t, then 1 over x squared would be t squared. So this would be t squared plus 2t minus 8 equal. So I let x to the negative 1 equals t. X to the negative 1 when you square it, you get x to the negative 2, which is 1 over x squared. Same thing. Okay. Trying to focus this. I don't know why I went out of focus. Okay. So now we can factor this. T plus 4, t minus 2 equals 0. So t plus 4 is 0. T minus 2 equals 0. T equals negative 4. But t is 1 over x. So x is negative 1 over 4. They're reciprocals, okay? 1 over x is 2. It's 1/2. Okay. That's all I wanted to do from this section. You can look at the notes. There's a couple more questions. Bye.